Alright, so we're going to look at some of the examples on properties or laws of logarithms. So looking at page 476, several different examples. We're going to start with number 2. Alright, so we're just going to expand. Alright, so that's going to be everything's to the fourth power. So that fourth power comes out and multiplied by the third law of Pogg's. So therefore that guy is going to become 4 times log base 2 of mn, and then you have 4 times the product of the of becomes an addition of two separate logs, log base 2 of m plus log base 2 of n, because remember the logs are the exponents. When you multiply with like bases, you're going to add the exponents. You could also distribute out that 4 if you wanted to. Either version would be fine as the solution. Alright, number 8 is the next one we're going to look at. Some of these you may have part of your homework, some are not. I'm just doing a bunch of different examples from the page. So log base 2 of 1 over mn. So therefore that's going to be a division first, so it's going to be log base 2 of 1 minus log base 2 of mn. So that's going to be log base 2 of 1 minus log base 2. Now be careful, they're both the minus, so that whole thing is going to be minus both of these. M plus log base 2 of n. Alright, now wait. What is log base 2 of 1? From our previous lesson we learned that log base 2, so 2, to what power is 1? Well, that's going to be 0. Now you can distribute out the negative as well if you wanted to, but basically this is just going to be negative log base 2 of m minus log base 2 of n. If you wanted to leave the negative undistributed, that would be fine as well. Alright, now I think this part's a little bit tricky for some, so I'm going to do 3 examples from this little section. They're giving you the facts that log base 10 of 9 equals 0.95 and log base 10 of 2 is 0.3. So what you do is take the numbers that they give us and break them apart to be some kind of version of the ones, either our laws that we know or the ones that they give us. So in this case, the 81, I could rewrite that as log base 10 of 9 squared. And therefore that becomes, by our third law of logarithm, the 2 gets to come out front, so it's going to be 2 log base 10 of 9. Now, this is the fact that they gave us. They told us that log base 10 of 9 is 9.95. So that means we know this guy is 0.95. It's going to be 2 times 0.95. Which is what? 1, 2, 18, 1.9. Oop. Alright, on the second one here we got 36. So how can I break apart 36 to use something that they give us? Alright, so that's going to be log base 10 of 9 times 4. So therefore that's going to be log base 10. And again, it is common log, so I don't really have to write the base there. But I'm going to keep writing because that's the way it was in the book. 9 times plus log base 10 of 4. Log base 10 of 9, they gave us that one, that's 0.95. Now 4 can be rewritten as log base 10 of 2 squared. The 2 gets to come out front, so 9.95 plus 2 times log base 10 of 2, which they gave us, so that's 0.95 plus 2 times, we got the 0.3 there, so that's 0.95 plus 0.6, so that's what, 1.55. Say, okay, we got the 1/3 power. Well, actually, let's rewrite that first as a power. Log base 10 of 2 divided by 9 to the 1/3 power. 1/3 power gets to come out front. Log base 10. I'm not going to write the base 10 this time. Save us some time. 2 divided by 9. That's going to be 1/3 log of 2 minus, because it's division, log of 9. So that's going to be 1/3. They gave us the 2, that's what, 0.3. They gave us the 9, which is what, 0.95. So we're going to subtract those, so it's 1/3 times 0.6. 5. So negative 0.215, so negative 0.22 direction set to 2 places. Alright, next set of examples from the next section, simplified with single logarithm. So we got a power out front there, so that's going to become log base 10 of 5 squared plus log base 10 of 4. The addition of two separate logs becomes a single log, and you multiply the ofs. That guy's going to be log base 10 of 5 squared is 25 times 4, which is 100. And of course log base 10 of 100 is 2. So this one simplifies all the way down to 2. Alright, then looking at this one, we have, now this one's an equation, so we're actually going to solve it. Can't do much on the left here, so we're just going to write that. I think that's an A. It's not nothing, that's an A. An example of the text. So the base is A, log base A of x equals, over here we can do some stuff. We get the power of 2, so that's going to become log base A of 3 squared plus log base A of 5. 3 squared of course is 9, so that's going to be log base A of 9 plus log base A of 5. It become log base A of 45. Now some of the stuff right now we should know is that, hey look, I got log base A on both sides. Alright, so the shortcut version is, alright, well I know log base A is the same, therefore the ofs have to be the same. That's by one of our definitions of logs. Alright, but technically what really happens there, we can use the inverse operation, and we know logs are the inverse of an exponential relationship. So if I'm going to actually take those and raise those as A raised to the log base A of x equals A to the log base A of 45. And then by our definition of log, we know that those are inverses, so they cancel out. And therefore A equals 5. That's technically the way we do it. But for most of us, the way we're going to do all this work is going to say, okay, once we get it to be log base A on both sides, and that's it, we know they cancel out. The ofs have to be the same. But the actual mathematical